The Agile Manifesto, known very well to people who build software with agile ways, with ways like Scrum. And it's just as much a driver for the people who want to develop industrial products with agile ways. So let's look at it, and I would like to give you my way of looking at it. What I did when writing it out on the whiteboard is I replaced software development with product development, and let's see how that reads to begin with. Reading the Agile Manifesto often jumps right into the 4 values. And yes, those are important. And so is that very first sentence. We are uncovering better ways of developing products by doing it and by helping others do it. That indicates the whole thinking around agility, the inspecting, the learning by doing, by making mistakes, and then by adjusting the way you made that mistake so that you don't make the same mistake twice. And that drives the iterative nature, the plan, do, inspect, adapt cycle in agile ways, in agile frameworks like Scrum. And Agile, by its name, does do that really, really fast. If you look at Scrum, 2-week cycles are very typical. We'll come back to that topic in the video about Scrum. So don't forget that very first sentence, the plan, do, inspect, and adapt cycle is key to being agile. Through this work, we've come to value, the 4 values. What I did is writing them and then thinking when a value says individuals and interactions over process and tools, think about it, what it says when you replace that word over by helped by. So people and how they work together are helped by process and tools. Process is a necessity. When you're running large, complex projects, think about missiles, think about chip technology, IC development, then that's not short and quick. That will take months, if not a year or longer. There is process in it. We'll come back to that when we talk documentation, there are sign-offs between supplier and the customer, absolutely. And some customers are really heavy on sign-offs and following through on that. All true. Tools, we need tools, not only to do our engineering work, like a CAD system, but also to support that interaction part between the people who work on that new system, on that new product. At the moment of recording this video, we're in the middle of the COVID-19 pandemic, and there are lots of tools at the moment becoming really popular, like Zoom, in order for people to communicate while they're working from home. Not all work can be done from home, and there are often remote people. So tools, absolutely necessary. Process, let's not forget about it. And they are supporting how people together create that new product. That's the first value. Second one, working product, helped by comprehensive documentation. Documentation, again, it's output of design thinking, your CAD system, your chip simulations, whatever you're working on, and as such is a necessity. And I already touched on it with process, and often it's the point where you get sign-offs, as in, yep, this is exactly the product or the part that we customer wants. As such, there's a necessity for it. Although engineers sometimes say like, yeah, no, nobody reads the documentation, so we might as well skip it. No, you can't, because documentation does get used. How you write it is another question. Can you document in your CAD system rather than in a separate Word document? Separate discussion. So the documentation helping to create a working product, because the working product shows how things really work or not work. You can simulate a design of a product, say that missile, You can design it and you can run it through simulations in your CAD system. And the moment that you put a real missile in a test environment, then you see what the real thing does do. With that inspect, adapt sequence that we talked about earlier, working product can be tested, can be inspected, and then adapted really early on. You don't need a full missile to have it running through a wind tunnel. You can print a scale model. Well, it's not perfect, but you can definitely learn from it. And with that, getting information, learnings, better than what the CAD design system says. If you now combine the first and second two values, then bring two design groups or design people together and put that optic into the mechanical design, and now run your tests and see how it works, and do that really early. Even a piece of plastic, a 3D printed optic, of course, it's never going to work, but you can check whether your mechanical structure can hold it and how it works there. Simple examples, you will make it a lot more complex in your environment, but again, it's about the thinking behind the manifesto. Working with your customers rather than doing contract negotiation. And contract, any design document is a contract. It's not just legalese, that's the contract. A design document signed off, process and tools, it may have to change. You might work through that working product and testing it, and then see that the way that the lens was shaped, the optics were shaped, that it doesn't fit and work in mechanical environments. Now work with your customer to see where can we make adjustments, rather than saying, no, we have a sign-off, work on it. Customer collaboration, not without contracts or signed-off designs, but helped by signed-off designs. Then responding to change over following a plan. If you're just that little bit longer in industry and you've gone through your first couple of projects, you know that projects never work by the plan. So you might even argue that that sentence is an open door getting kicked in. Well, maybe, but think about it. A plan is often leading, and a customer, contract negotiation, saying, hey, thou shalt. Thou shalt is not necessarily the best and the fastest way. So build into your process, and there's the relation, a way to change your plan. You're running your inspection, you got your working products, and you see that, we have to redo this design, or we can, because this solution works really well, make a few shortcuts. Everything is inspected, including the plan, and plans will change. Everything I said is different. Everything that will come out of observing what you're doing and then continuously change what you're doing and doing that really fast, the 2-week Scrum cycle, that's new to you. It will get you out of your comfort zone. It will make you feel uneasy. What do we do if there's no master plan? Well, then you build a master plan. There is a master plan. All those things have to be learned, and that unease, that being out of your comfort zone, that is where you learn. That is what that first sentence says. You have to change, and you have to be uncomfortable to get, as we say in the company, twice the product in half the time.